Did you know that over 1.1 billion ducks are raised around the world each year? An astonishing figure. 3 times the population of the United States? This remarkable journey begins with healthy flocks raised on large-scale farms, cared for meticulously and supported by state-of-the-art processing facilities. The result? Golden, nutrient-packed duck eggs and succulent, tender duck meat, boasting higher iron levels than industrial chicken and more omega-3s than salmon. Duck has earned its reputation as a nutritional labyrinth, highly prized by food connoisseurs worldwide. Today, join Agriculture Insight as we explore some of the world's most advanced duck meat and egg processing plants and unveil the secrets behind this vibrant and fast-growing industry. Although China is hailed as the duck capital of the world, home to 97% of the global duck population, the United States has earned the title of the modern duck factory of the world. With renowned farms like Hudson Valley Foie Gras and La Belle Farms, the U.S. has turned its massive domestic market into a solid launching pad, propelling itself to the forefront as a leading duck exporting empire. One fascinating and remarkable fact is that the male duck's reproductive organ is shaped like a tightly coiled spring, stretching up to 3 times the length of its body. With this unique weapon, male ducks can swiftly attract mates, displaying astonishing speed and adaptability to all environmental conditions. While duck meat dazzles on the dining table with its golden, crispy skin and irresistible aroma, in the wild, ducks are notorious as one of the smelliest boilers in the poultry world. Their waste contains up to 80% moisture, which easily releases ammonia odors, forcing farms to clean duck housing twice as often as for chickens. Yet duck manure is also hailed as black gold in agriculture, highly valued for enriching crops and revitalizing fish ponds. The journey of ducklings begins at breeding farms, where each egg is carefully selected to ensure the highest quality. After selection, the eggs are placed in special incubation trays and transferred into automated incubators. The temperature inside is maintained steadily at around 37.5 degrees Celsius, while lighting is adjusted to mimic the natural day-night cycle, creating a warm and ideal environment for the eggs to develop evenly and healthily. If the temperature is not properly maintained, either too high or too low compared to the standard, it can directly affect the development of the embryo, potentially causing damage or preventing the egg from hatching. After about 28 days, the ducklings begin to hatch, gently tapping the eggshell with their beaks before carefully emerging. Their tiny eyes peek open and they take hesitant, wobbly steps, yet full of life. It is a magical moment that marks the beginning of a brand new journey. The ducklings instinctively gather together, exploring and getting familiar with their surroundings. Shortly after hatching, they are vaccinated to prevent diseases and protect their health from the very first days. Ducks are the poultry species with the highest susceptibility to avian influenza worldwide. As a result, the antibiotics and vaccines used are thoroughly researched to ensure high effectiveness in preventing serious diseases such as avian flu and enteritis. This helps minimize the risk of outbreaks and safeguards the health of the entire flock. Healthy and qualified ducklings are sorted and transferred to rearing farms. They are placed in transport crates and gently delivered to locations that offer the best care conditions. The ducklings may be transported by boat, gliding smoothly over the water, or by specialized vehicles to the farms, where they will continue to be cared for and nurtured to grow strong and healthy. Right after being safely transported from the breeding farm, the ducklings are warmly received by the farm owners and transferred to a specialized care area. As the boats gently dock, the ducklings are carefully moved into their dedicated care zones. Here, they are raised in a closely monitored environment to ensure optimal growth and well-being. At traditional farms, ducklings are released into spacious pens where they can roam freely and have easy access to food and water, creating a natural, comfortable environment that supports healthy development. Meanwhile, in modern farms, automated systems regulate their feed and water intake, saving time and minimizing human intervention. The ducklings are fed a specially formulated, nutrient-rich feed that provides all the essential vitamins and minerals, Compared to chicks, ducklings require higher levels of protein and energy. Their feed is also adjusted to support their digestive system, which is naturally adapted to a more water-oriented environment. They are introduced to water at an early age, allowing them to drink and learn to swim as they grow. This not only helps maintain their overall health, but also supports their digestion and lays the foundation for their full development throughout the growth process. After about 5 to 6 months of careful care, once the ducklings have fully matured, they are transferred to other farms for egg or meat production. Unlike other types of poultry, ducks have webbed feet and tend to move slowly, making them prone to slipping and falling when crowded. To address this, farmers typically use specialized mesh pens combined with sloped ramps that create a narrow pathway, like a duck elevator, allowing the ducks to gently walk up on their own. This method ensures their safety and helps reduce stress throughout the journey. A mature female duck can produce 200 to 250 eggs per year, especially during the spring and summer seasons, providing an abundant and high-quality source of eggs for the market. However, unlike hens that diligently brood their eggs, ducks are known to be rather careless mothers. After laying, they often leave the nest immediately, showing little interest in nurturing their offspring, leaving the incubation entirely to humans. This carefree behavior requires farmers to be especially skillful in collecting and preserving the eggs to ensure their quality and safety. After duck eggs are collected, a portion is processed into salted duck eggs, a flavorful delicacy beloved by many. The process begins with thoroughly washing the eggs to remove all dirt and impurities from the shell. Each egg is then carefully inspected to select only the unfertilized ones, ensuring optimal quality for the final product. Next, artisans prepare a curing mud mixture, typically made from red clay, white salt, and water, stirred until smooth. Depending on the production scale, this step may be done by hand or with the help of machines. Once the mixture reaches the desired consistency, it is applied to the eggs, forming a thick, armor-like coating. This layer allows the salt and minerals to slowly penetrate the shell throughout the curing period. A single batch of this curing mud can coat about 150 eggs. After being coated in the curing mud, the eggs are placed in a warm, shaded environment, away from direct sunlight, and left to cure for about 30 to 40 days. This is the period when the eggs hibernate, slowly settling and absorbing the essence of the natural seasonings, allowing a magical transformation to occur within the yolk. Once the curing period is complete, the eggs are removed and carefully washed to clean off the layer of mud. Although the outer appearance of the eggs remains unchanged, this is when the most magical transformation is revealed. When cracked open, the yolk appears in a deep crimson hue, resembling precious gems, soft, translucent like jelly, and glowing with a pure, radiant beauty. After any remaining egg white is rinsed off, the yolks are neatly arranged on trays. A light mist of alcohol is then sprayed over them, not only for preservation, but also to enhance the unique flavor of the salted eggs. Finally, the salted egg yolks are carefully packed into storage bags or immediately used in iconic dishes, such as mooncakes with salted egg yolk, salted egg fried rice, or salted egg custard buns. These dishes are elevated by the rich, savory, and creamy flavor of the yolks, adding depth and perfection to every bite. Salted duck eggs are not just a treasured ingredient in the kitchen, they are also an essential part of Asian culinary culture. For meat ducks, the process begins when the ducks are gathered from their enclosures and transported by specialized trucks to the processing plant. When the ducks arrive at the processing plant, they are immediately taken to specialized areas designated for the initial preparation stage. Skilled and well-trained workers carefully carry out all necessary steps to thoroughly prepare the ducks for the subsequent processing stages in an efficient and meticulous manner. This preparation process includes important tasks such as precisely and carefully removing the internal organs to ensure the meat maintains optimal quality and meets the technical requirements for the following processing steps. At the same time, the entire outer surface of the ducks is thoroughly cleaned, completely removing dirt, impurities, or any unwanted materials adhering to the skin. All these steps are supported by modern automated production lines, specially designed to make the entire process faster, more accurate, and much more efficient compared to manual work. The application of advanced technology equipment not only shortens the time required to complete these tasks, but also enhances uniformity and guarantees absolute food hygiene and safety throughout the preparation process. After the processing stage is completed, the ducks are transferred to a specialized chilling system designed to preserve and maintain the optimal freshness of the meat. In this step, the ducks are thoroughly immersed in a cold water bath with strictly controlled temperatures, enabling rapid and efficient cooling of their bodies. This quick chilling process not only helps retain the quality of the meat, but also prevents bacterial growth, thereby avoiding spoilage or deterioration caused by residual heat from previous stages. Immediately after the cold water immersion, the ducks are carefully removed and hung on specialized racks inside a chilling chamber. This chilling chamber is large-scale and highly efficient, capable of handling hundreds of ducks per hour, while ensuring uniform and effective cooling throughout the entire process. Hanging the ducks vertically allows cold air to circulate evenly around the meat surface and facilitates effective drainage, reducing excess moisture on the meat. This step is crucial to preserving the meat's original quality throughout subsequent processing stages, ultimately enhancing the final product's value when it reaches consumers. After being thoroughly chilled and sprayed with cool water to retain moisture, the ducks are carefully packaged to preserve their freshness and ensure safety throughout the transportation process to the next stages of processing. Next, the ducks are transported to specialized processing facilities, where the roast duck preparation officially begins. The ducks may either be fully immersed in a pot of boiling water or hung on hooks while hot water is poured evenly over their bodies. This helps the skin become smooth, taut, and perfectly prepped to achieve that signature crispness after roasting. Notably, the boiling water isn't just plain. It's infused with natural herbs and spices such as mugwort leaves, lime leaves, and peppercorns, creating a subtle aroma that gently seeps into the skin. This step not only enhances the flavor, but also sets the stage for a deeply savory and aromatic marination process that follows. After the scalding process, the ducks are left to drain thoroughly before being placed into the roasting oven. The oven is set to a high temperature, and the ducks are roasted for about 30 to 40 minutes. This allows the skin to become golden and crispy, while the meat inside remains juicy and tender. Once the duck is fully cooked, it is chopped into bite-sized pieces. The crispy skin and the tender, juicy meat inside offer a rich and savory flavor. The hot, freshly roasted duck pieces are arranged on a plate, ready to be served. With its bold flavor, crispy and flavorful skin, and naturally sweet, tender meat, roast duck is the perfect dish for festive gatherings or cozy family meals. Once revered as the sacred mother in ancient India, the dairy cow today is not only a humble source of nourishment for millions of families around the world, but also a lasting symbol of the modern global agricultural industry. But have you ever wondered how billions of dairy cows are raised, milked, and processed every year? It all begins at vast organic pastures and large-scale modern dairy farms, where these gentle animals are raised, fed, and cared for with the deep experience of dedicated farmers. Through strict control systems, streams of fresh milk are swiftly transported to specialized processing facilities, where skilled workers and advanced technology work hand in hand to turn that milk into bottled milk, creamy butter, rich cheese, and many other delicious dairy products. Today, Agriculture Insight invites you into the world of dairy farming to discover how this humble animal has become one of the most profitable heroes of modern agriculture. Right now, let's dive into this fascinating journey. Are your cows truly living a happy life? When cows are happy, they give back in the best way they know how, with rich, creamy milk. But when stress creeps in, whether it's a noisy barn, a sudden change in routine, or just a grumpy farmer in a bad mood, milk production dips, the barn gets tense, and suddenly, even the cows aren't smiling anymore. Modern dairy farming represents a true revolution, a dramatic leap from the traditional practices that sustained human civilization for over 8,000 years. And today, producing over 900 billion liters of milk each year is no longer the sole measure of success. That's why more and more farmers are returning to their roots, adopting pasture-based and organic dairy farming models. Instead of confining cows in enclosed industrial barns, these farms allow them to roam freely for 6 to 12 hours a day on wide-open pastures, living according to their natural biological rhythms. Each cow is milked only once or twice a day, usually in the morning and afternoon, and only when they are truly ready, producing cool, nutrient-rich milk at its best. These pasture-based and organic models are mainly concentrated in Europe, New Zealand, Australia, and certain U.S. states such as California, Oregon, and Vermont, where mild climates, abundant grasslands, and ethically minded consumers create the ideal conditions for sustainable dairy. Milk yields in these systems are lower, at just 15 to 25 liters per cow daily, but the milk is higher in quality, with more natural fats, omega-3s, and minimal residues. However, due to higher costs and lower yields, organic dairy models are still unable to meet the growing global demand for milk. As a result, industrial dairy farming now accounts for over 90% of the world's total milk production and continues to play a crucial role in the global food supply chain, delivering economic value, high productivity, and operational stability that smaller-scale systems have yet to match. And to keep that massive dairy empire running, everything begins with vast green pastures, where grasses like alfalfa, oatgrass, ryegrass, and corn are carefully cultivated, officially entering the harvest season in late spring or early summer. Farmers invest in advanced machinery such as the John Deere or Krone EasyCut series, which use traditional rotary shaft or horizontal disc cutting systems. Immediately after being cut, the grass passes through a conditioner unit, which uses rubber rollers or metal tines to gently crimp the stems. This process helps the grass dry more evenly and creates ideal conditions for fermentation during the ensiling process that follows. After harvesting, the chopped forage is transported and dumped into a bunker silo, a large concrete or tarp-covered trench that can hold anywhere from several hundred to several thousand tons. Inside the silo, the forage is tightly compacted using trucks or rollers to remove air, then sealed with plastic sheets weighted down by tires or sandbags, creating anaerobic conditions where lactic acid bacteria ferment the material, lower the pH, and prevent spoilage. Once all the ingredients are ready, they are loaded into a TMR mixer to create a balanced feed tailored to each stage of the cow's development. If you're managing a herd of 10,000 dairy cows, the average daily feed requirement would be around 250 tons of silage, 50 tons of hay, 80 tons of ground corn, 40 tons of soybean meal, and 2 tons of minerals and vitamins. That's why, for many American farmers, dairy farming isn't an easy job. It's a lifelong investment, a treasured asset, and a symbol of pride passed down through generations. After the feed is mixed, an automatic feed pusher moves along the barn aisle, pushing the feed closer to the trough to make it easier for the cows to eat and to reduce waste. Though they may experience happiness in different ways, dairy cows raised on modern farms are still provided with dedicated welfare measures to help them achieve optimal health and productivity. Regular health checks are strictly carried out, from monitoring temperature and hoof conditions to observing gait and breathing patterns. Cows also receive routine hoof trimming to prevent infections and ensure they can stand and walk comfortably. Much like familiar pets such as dogs and cats, cows enjoy being stroked, scratched, and soothed after meals. That's why some farms have installed automated massage systems, gently rotating brushes placed right inside the barn, allowing cows to relax, reduce stress, and stimulate blood circulation. After around 15 to 16 months, the cows reach maturity and take on a greater mission: to give birth to the next generation, ensuring that the flow of milk never stops. This begins with one of the most important steps in dairy farming: fertilization. To better control breeding timing and optimize reproductive efficiency, most modern farms have adopted artificial insemination with the support of advanced technology. The exact timing of ovulation in dairy cows can now be pinpointed down to the hour, ensuring higher success rates and more efficient herd management. After 9 months of pregnancy, the mother cow gives birth to a calf, a sacred moment, but one that is far from easy. Calving can be quite challenging, especially for first-time mothers, and often requires direct assistance from the farmer to ensure the safety of both the cow and her newborn calf. But not all of these calves will get the chance to become mothers. After birth, male calves are typically separated from their mothers and sent to specialized facilities where they are raised for beef or veal production, although some may be selected for breeding if they show good genetic traits. Meanwhile, female calves are usually kept on the farm and raised in individual pens, bottle-fed, and carefully monitored for nutrition and health on a daily basis, because these young heifers are considered the future milk machines of the farm. After giving birth, this is the golden moment when the mother cow officially enters her lactation phase, which typically lasts around 9 to 10 months. Before milking, the udder is carefully cleaned with warm water and a sanitizing solution, then dried with a soft towel, and each teat is briefly checked for any signs of infection or inflammation. This step is crucial. Not only does it ensure milk hygiene, but it also helps the cow feel relaxed and comfortable, making her more ready for the milking process. When it's time for milking, the mother cows are guided to an automated milking station where the process is smooth and stress-free. The automated milking system gently attaches to the udder, mimicking the natural sucking motion of a calf. Each cow can produce around 30 to 40 liters of milk per day, and that's why, at large farms, total daily production can exceed 50,000 liters, enough to fill a small swimming pool. The milk flows directly through a closed pipeline system into a stainless steel cooling tank, kept at 4 degrees Celsius to preserve freshness and prevent bacterial growth. And that's just one half of the cow's journey. Within just a few hours of being collected, the milk is transported in specialized insulated tankers to the processing plant, where the second half of its journey begins, transforming into fresh milk, butter, cheese, or meat for millions of families. First, for dairy-based products. As soon as the tankers carrying tens of thousands of liters of milk arrive at the factory, the fresh milk is pumped into large stainless steel storage silos. Before entering the main processing line, each batch of milk must undergo a strict quality control process. Samples are tested to measure fat content, protein levels, pH, and most importantly, to check for microbial contamination, antibiotic residues, and impurities. If a batch of milk fails to meet the required standards, it is immediately rejected and never enters the production line. To produce fresh milk or butter, the process always begins with an essential preliminary step: cream separation. Although this step carries the same name, the way fat content is handled can vary, and if you're not paying close attention, it's easy to get confused. In cow's milk, since the natural fat content can fluctuate, the milk is first pasteurized and then separated into cream and skim milk using a centrifuge, leaving the skim milk with a residual fat content of around 0.05% to 0.1%. That's why, after separation, an exact amount of cream is added back into the skim milk to create different types of milk with specific fat levels, such as whole milk around 3.25% fat, reduced fat milk, typically 2%, low-fat milk, or fat-free milk, 0.1%. However, when cream is separated for butter production, the process is handled differently. The cream is kept in its natural liquid form, with a fat content ranging from 35% to 40%, and it becomes the key ingredient for churning those golden, smooth, and richly flavored blocks of butter we all know and love. The milk is then passed through a homogenizer, where large fat globules are broken down under high pressure and evenly dispersed throughout the liquid. This process prevents the milk from separating, preserves a smooth texture, and makes it easier to digest. To ensure safety, the milk is pasteurized once more before entering the packaging stage, where it is prepared for distribution to consumers. Meanwhile, the cream collected during the earlier separation stage is further processed to produce butter. Before moving on to the churning stage, the cream must be pasteurized to eliminate harmful bacteria while preserving its natural flavor. It is quickly heated to 72 degrees Celsius for 15 seconds, just enough to kill bacteria without affecting the fat or flavor, and then rapidly cooled to prepare for the butter churning process. Next, if cream separation is the foundation of milk production, then churning is the heart of the butter-making process. The cream is poured into an industrial butter churn and continuously agitated to break down the fat structure. At first, the cream gradually thickens, and then tiny butter granules begin to form and clump together into smooth, solid butter. The remaining liquid, known as buttermilk, is separated and collected for use in other products, such as baking goods, salad dressings, or cultured dairy drinks. After the butter has formed, it is washed with cold water to remove any remaining buttermilk, helping it last longer and preventing it from turning sour. A specialized machine then kneads and mixes the butter to achieve a smooth, uniform texture. Flavorings such as salt or herbs can be added at this stage to enhance taste and create different butter varieties. This is the step that defines the unique flavor profiles of famous butter brands like Land O'Lakes, Kerrygold, or President. Once the butter reaches the desired smoothness, fat content, and flavor, it is transferred to a molding machine, where it is shaped into sticks, blocks, or larger portions, depending on the intended use. While dairy butter continues to dominate global production, vegan butter, typically made from plant-based ingredients like coconut oil, soybean oil, or avocado, is quickly gaining popularity thanks to the rising demand for plant-based diets and sustainable alternatives, offering a similar taste and texture without any animal products. When it comes to cheese, the journey of cow's milk takes an entirely different turn, contributing to a global consumption that exceeds 21.6 million metric tons each year. After the milk is pasteurized and stabilized, lactic acid bacteria are added. These beneficial microbes begin the fermentation process, converting lactose into lactic acid, creating the ideal environment for the milk to coagulate. Next, rennet enzyme is introduced, causing the milk proteins, primarily casein, to bond together and form a solid mass known as curd. In traditional cheesemaking, natural rennet is often used, extracted from the stomachs of young male calves that are not kept for dairy herds, and obtaining this enzyme requires the calf to be slaughtered at a very early age. In contrast, in large-scale modern production, where millions of tons of cheese are made each year, rennet is typically produced through biotechnology to reduce costs and ensure consistent quality. Once the milk has fully coagulated, large blades gently cut the curd into small cubes, allowing the whey, the liquid portion, to separate from the solids. The curds are then continuously stirred and gradually heated, causing them to shrink and release more moisture. The temperature and duration of this process play a crucial role in determining the cheese's texture, whether it ends up soft like mozzarella or firm like cheddar. Once the curd is firmed up, the liquid whey is separated. This byproduct serves as the raw material for producing whey protein, a widely used nutritional supplement in bodybuilding, sports nutrition, and medical diets. The remaining fresh cheese is placed into molds and pressed under high pressure to shape it and further expel excess moisture. The amount of pressure and pressing time directly influence the final moisture content of the cheese, a critical factor in distinguishing different cheese types. After pressing, the cheese is removed from the mold and enters the next essential stage, salting. Cheese can either be soaked in a brine bath or have salt rubbed directly onto its surface. Salt not only enhances flavor, but also helps regulate moisture, form the rind, and inhibit the growth of harmful bacteria. After salting, the cheese wheels are transferred to an aging room where temperature and humidity are carefully controlled. Depending on the type of cheese, the aging process can last anywhere from a few days to several years, and it is this stage that defines the cheese's richness, texture, and distinctive aroma. Have you ever wondered what happens when mother cows can no longer produce that sweet, nourishing stream of milk? They leave the farm, closing the chapter of milk and opening a new one, where every cut of meat continues the story of devotion and purpose. Before entering this final stage, thousands of dairy cows are given a period of rest, typically around 24 hours, after a long journey of transportation. While countries like India treat cows as sacred and focus primarily on dairy, others, like Japan and members of the European Union, are advancing strict animal welfare standards, proving that cow farming is as much about culture and values as it is about food. After the cow is restrained and comes into contact with the electrodes, an electric current of 1.5 to 2.5 amps is passed through the brain for about 3 seconds, rendering the animal unconscious instantly and ready for the next stage of the process. After the carcass has been suspended and the legs removed, the hide removal process officially begins, a critical step that requires seamless coordination between skilled workers and modern machinery. Once activated, a rotating drum gradually pulls the hide away from the carcass in a clean and even motion, without damaging the valuable meat underneath. The entire process is swift but demands high precision to ensure the quality of both the hide and the meat is preserved. Dairy cow hides are generally not used to produce high-end leather goods like handbags or dress shoes, as their fibers are looser and the hides are typically thinner and lower in quality compared to beef cattle hides. Instead, they are more commonly used for industrial purposes, such as making gloves, leather mats, or recycled leather materials. After the hide and internal organs are removed, the carcass undergoes a final inspection by the quality control team. If it meets all required standards, it is stamped with a health inspection mark or affixed with a certification label, confirming that the meat is safe and ready for commercial processing. The clean carcass is then transferred to a blast chilling room, where the temperature is maintained between 0 and 4 degrees Celsius. Once the carcass reaches the required temperature, it is moved into the deboning and cutting area. However, unlike premium beef breeds known for their rich marbling, tenderness, and juiciness when grilled, meat from older dairy cows tends to be tougher, leaner, and less visually appealing. Instead, most of the meat is sent for industrial processing, turned into products like sausages, pâté, meatballs, or ground beef. Thanks to its strong flavor and firm texture, this type of meat is especially well suited for slow-cooked dishes or recipes requiring high heat. From the first drop of milk to the final cut of meat, the life of a dairy cow is a story of devotion, transformation, and the unseen journey behind the food we often take for granted. Hello everyone. Welcome back to Agriculture Insight. 2.5 million pounds is an impressive amount, and that's how many sweet potatoes American farmers harvested in 2024. Today, join me as we explore the fascinating journey of this essential crop. From the rich, fertile fields of states like North Carolina, California, and Mississippi, to the modern facilities where sweet potatoes are packed and prepared for market, we'll dive into every step. We'll discover how farmers harvest these nutritious roots with care and precision, and how advanced technology ensures they reach your table in perfect condition. Now let's uncover the incredible process behind sweet potato farming in America. Sweet potatoes are one of the standout crops in American agriculture, playing a crucial role in supplying nutritious and versatile food for households and the food industry. Every sweet potato story begins in the field. First, soil preparation is an extremely important step. The soil for growing sweet potatoes must be plowed thoroughly to create porosity and good drainage, helping the potatoes to grow evenly and avoid rotting. After plowing the land, a ridge maker is used, and the ridges are covered with plastic to help the sweet potato plants grow easily and avoid weeds. Once the land is prepared, the sweet potato planter is brought in. Sweet potatoes are usually grown from stem segments of the sweet potato plant for seed, called sweet potato cuttings. The planter is usually designed with a seat at the back for the planter. The farmer will place the sweet potato cuttings into specialized slots on the machine, ensuring that the planting is done accurately and regularly. After about 3 months from planting, sweet potatoes may be ready for harvest. They are ready when the leaves start to yellow and wither, indicating that nutrients have concentrated in the tubers. The process of harvesting sweet potatoes with machinery typically starts with a specialized vine-cutting machine. This machine moves along the rows, trimming the leaves and vines on the surface, making it easier to harvest the tubers. Next, a sweet potato harvester digs into the soil and gently lifts the tubers out without causing damage. The potatoes are then transferred onto a built-in conveyor system where they undergo preliminary cleaning to remove dirt and debris. Workers positioned along the conveyor quickly sort the potatoes, removing any damaged or substandard ones. Finally, the quality sweet potatoes are collected and prepared for transport to storage facilities or processing plants. This process not only saves labor, but also ensures speed and efficiency across large-scale fields. The United States is one of the world's largest sweet potato producers, with an annual output of about 3 million tons, primarily from states like North Carolina, California, and Mississippi. Sweet potatoes are not only a nutritious food source, but also play a significant role in the U.S. economy, particularly in exports and the food processing industry. The popularity of sweet potatoes also reflects the growing trend of healthy eating in the lives of Americans. On other farms, the sweet potato harvesting process is more modern, with a single integrated machine that achieves incredible efficiency and precision. The process begins with an automated sweet potato harvester, equipped with durable digging blades that cut into the soil at just the right depth. These blades carefully lift the soil and sweet potatoes, tipping them onto a conveyor system designed to minimize bruising or damage to the delicate tubers. As the sweet potatoes move along the conveyor, a series of brushes and separators gently remove soil, roots, and other debris, ensuring the harvested tubers are clean and intact. The machine's sorting mechanism also allows workers on the harvester to visually inspect and remove any damaged or undersized sweet potatoes in real time. Once cleaned and sorted, the sweet potatoes are transferred to a spacious holding tank or directly into shipping containers. This streamlined process not only reduces manual labor but also increases the speed and quality of harvest, helping farmers maximize yield while maintaining crop integrity. Another machine with a longer conveyor belt. The highlight of the machine is the extended conveyor belt, which allows the sweet potatoes to be transferred directly from the harvester to containers on a tractor moving alongside. Thanks to this design, the sweet potatoes are harvested continuously without stopping to load and unload, saving time and effort. After being harvested, sweet potatoes are transported to a processing facility to begin the handling process. First, the sweet potatoes are cleaned using an automated washing system that removes dirt, dust, and surface impurities. The washing machine uses high-pressure water jets combined with rotating brushes to thoroughly clean the surface of the sweet potatoes without damaging their skins. After washing, the sweet potatoes are quickly dried using air blowers or a gentle drying system, preparing them for the next steps of sorting and packaging. The sweet potatoes are then placed on an automated conveyor belt to proceed to the sorting and packaging stages. On the conveyor, the sweet potatoes move steadily through systems equipped with sensors or smart cameras, which detect those that do not meet standards for size, shape, or show signs of damage. Additionally, workers stationed along the conveyor assist in removing defective sweet potatoes that the machines may not identify. Quality-approved sweet potatoes continue to the packaging area, where automatic weighing machines ensure the correct quantity or weight for each package. Finally, the sweet potatoes are placed into packaging, sealed, and labeled before being prepared for storage in cold warehouses or transport containers. This process ensures precision, efficiency, and optimal product quality when reaching consumers. Moreover, the packaging process is carried out by robotic arms with remarkable precision and efficiency. Equipped with a specialized gripper, the robot gently lifts the sweet potatoes without damaging their delicate skin. Guided by high-resolution cameras and sensors, the robotic arm identifies the sweet potatoes on the conveyor belt, adjusts its movements in real time, and swiftly places each one into designated cardboard boxes. So we've explored the journey of sweet potatoes from farm to table. But there's another sibling that's even more popular: the potato. Much like sweet potatoes, potatoes are also harvested from vast fields with the help of modern machinery. The United States is one of the world's leading potato-producing countries, with an average annual output of approximately 44 million tons. The potato harvest season in the U.S. typically takes place in the fall, from September to November. Potato harvesters used on large fields operate based on a combination of mechanical and automated principles to optimize the harvesting process. First, specialized blades or digging tools gently cut and lift the soil, carefully extracting potatoes without damaging the tubers. The potatoes are then transported onto an integrated conveyor system, where vibrating and sorting mechanisms remove soil, small stones, and other debris. An automated or manual sorting system ensures that only potatoes meeting the required size and quality standards are retained. The qualified potatoes are transferred to an integrated storage compartment or a long conveyor belt that loads them directly onto waiting trucks, minimizing downtime for unloading. The entire process is continuous, fast, and precise, saving labor, optimizing time, and maintaining product quality. With the ability to cover vast areas efficiently, this type of harvester is an essential tool for large-scale potato farms. Potatoes are one of the standout crops in American agriculture, playing a crucial role in providing nutritious and versatile food for households and the food industry. They are primarily cultivated in states like Idaho, Washington, Wisconsin, and North Dakota, where the climate and soil conditions are ideal for potato growth. Idaho alone accounts for nearly 1/3 of the nation's production. earning its reputation as the potato capital of the U.S. While potatoes are a cornerstone of American agriculture, they also thrive in other parts of the world. Countries like China and Russia are among the largest producers globally, thanks to their favorable climates and long-standing agricultural practices. Farmers in these regions, much like in the U.S., combine traditional farming methods with modern technology to maximize yields and ensure high-quality crops. After harvesting, potatoes are transported to processing facilities, where they are thoroughly cleaned and sorted. Next, potatoes that meet quality standards are sent to automated packaging systems, where they are weighed and packed into suitable packaging, such as mesh bags or cardboard boxes, to ensure ventilation and protection during transportation. The packaging is then securely sealed and labeled with complete product information, including origin, packing date, and quality standards. Finally, the packaged potatoes are neatly stacked and stored in cool storage before being distributed to the market, ensuring they reach consumers fresh and safe. Next, let's explore the potato chip making process. It begins with selecting high-quality potatoes, which are washed, peeled, and sliced into thin, uniform pieces. These slices are quickly rinsed to remove excess starch and then fried in hot oil at a controlled temperature until they become crispy and golden. After frying, the chips are seasoned with salt or a variety of other flavors, depending on the recipe. Finally, they are cooled, packaged into airtight bags, and sealed to maintain freshness before being distributed to stores. Potato chips are one of the most popular snack foods in the United States, enjoyed by millions of people across the country. Known for their crispy texture and salty flavor, they are a staple at parties, picnics, and game nights. The process still begins with selecting high-quality potatoes, washing them, peeling them. They are then fed into modern cutting machines to be cut into shapes like slices to make potato chips. They are rinsed with clean water again to ensure no chemicals remain. Looking at these potato slices, do you find them appealing? Post-blanching, potatoes are dried to remove moisture on the surface. This step is crucial for achieving the desired texture in fried products and also helps in extending the shelf life. The dryer uses hot air to circulate around the surface of the potatoes to cook and crisp them. Potatoes will be dried within 15 to 20 minutes. Frying with heat does not require the use of cooking oil, helping to reduce the amount of fat and calories in French fries. Potatoes are crispy on the outside, but may be less crispy than fried in oil. However, this method still retains the moisture and flavor of the potatoes. French fry products are cooled at room temperature or with forced air. Engineers control the entire process through a monitoring system. This process is fully automated by machines. The crispy potato slices are out of the oven. They are divided into specific portions for packaging. The final products are then packaged in a controlled environment. Packaging is designed to protect the product from air, moisture, and other external factors that could degrade its quality. Packaged products are stored in warehouses at controlled temperatures until they are distributed to retailers or directly to consumers. In addition, the factory has a laboratory available so that professors can measure the safety and nutrition of products before selling them on the market. French fries are an iconic and widely loved dish in the United States, often seen as a must-have side for burgers, sandwiches, and steaks. Their golden, crispy texture and versatility, from classic fries to curly, waffle, and seasoned variations, make them a favorite for people of all ages. As a staple in fast food chains and fine dining alike, French fries have become a symbol of American comfort food culture. We've just explored the incredible journey of humble potatoes and sweet potatoes, from the vast fields where they're grown to the careful harvesting and processing that transforms them into the products we enjoy every day. Thank you for joining me on this adventure. Don't forget to like, subscribe, and stay tuned for more fascinating stories about the world of agriculture. See you in the next video.